Section 21-1, the power rule. So let's first go over the definition of the power rule. We've practiced calculating the derivative, and we did that using the difference quotient. And essentially that was the limit as h goes to 0 of f of x plus h minus f of x all over h, right? The difference quotient, we were able to calculate the derivative, and it seemed tedious and long and a little bit annoying. Well, what we're going to do now is we're going to be learning a series of rules to be able to calculate the derivative of certain types of functions and certain types of instances. Basically, maybe you can think of them almost as like shortcuts per se. So the first rule we're going to look at is the power rule. Now that says that if y equals x to the c power, and c has to be a real number, so it can't be some imaginary number, then the derivative, you take the c, you move it to the front, so you multiply it, and then you subtract 1 from c. So we're just going to do a series of practicing these different instances over and over again. So I have y equals 2x to the 7th. So if I wanted to take the derivative, y prime, I multiply c, I move it to the front, so 2 times 7 gives you 14. Then I have to subtract 1, so 7 minus 1, that's going to give me x to the 6. And that's going to be the derivative. The next one, if I have a larger function, so y equals 3x squared minus 12x to the 4th plus 2. Bring it to the front. So that's 6x minus 1, so to the first power, to the front, gives minus 48x to the 3rd, because I have to minus 1. And then if you ever have a constant, the derivative of the constant is 0. And the reason is because this is 2x to the 0 power. Well, I bring that to the front, so 0 times 2x minus 1. Well, 0 times anything is 0, so that's why it turns into plus 0. And so my derivative is going to equal negative 48x cubed plus 6x. Now sometimes in this instance, we're going to have scenarios in which our values are in the denominator like this. Well, the power rule didn't address what happens when it's in the denominator. So we can actually manipulate the statement algebraically so that I can use the power rule. So this will become y equals negative 2x to the negative 3rd. So now using the power rule, multiply these two values together. And so I'm going to get equals 6, because negative 2 times negative 3 is 6. X to the, now I have to subtract 1, so minus 4. And so my derivative is going to be 6 over x to the 4th. In this instance, we're going to have to, be able to simplify this. So y equals negative 3x to the 3rd over 6x to the 7th. Those are going to reduce. And so will that. So I'm going to get y equals negative 1 over, now I have a 2 in the denominator, and it's going to be x to the 4th. So once again, I can bring this to the top. Now notice what I'm bringing to the top. It's just that value. That gets brought to the top. So then y equals negative x to the 4th over 2. So now I can take the derivative. Maybe another way of looking at this, I can say negative 1/2 x to the 4th, negative 4th. And then taking the derivative, multiply these two values together. So 1/2 times negative 4 gives me a positive 2. And then x to the negative 5th, that's going to go in the denominator. And so I'm going to get 2 over x to the 5th. Y equals negative 10. Simple. any constant, automatically 0. So my derivative is 0. Y equals 4x minus 2. Now the reason why I emphasized this one is because my power is 1 here. So I do multiply. So 1 times the 4, right? Those multiply. And so I get 4 still. Now x minus 1 is 0. Oh, sorry, the 1 minus 1 gives me the 0. And so that gives me x to the 0 power. And the derivative of negative 2 is 0. Well, anything to the 0 power is 1, and so my y prime is just 4. So this, it says, find the derivative of y in respect to x for dy. Now in this instance, we will learn a property or a rule to help us with this, but for now, the only thing that we can do is manipulate this statement to where we can then use the power rule. So x squared times x is x cubed. X squared times negative 1 minus 3x and minus 3. So now I can use the power rule. And so I get y prime equals 3x squared minus 2x minus 3, because the derivative of a constant is just 0. Now even pause it and take a look. You can double check. I multiplied the power with the coefficient and subtracted 1 every instance. And maybe because it says dy over dx, you could also write it like that. For the next one, this one here we can simplify. So y equals 3x to the 4th squared. The square goes to both, so that's 3 squared times x to the 4 squared, so that's x to the 8, which is just 9x to the 8. So then the derivative would be 72x to the 7th. Now this one is a little tricky. So once again, we're going to have to manipulate our statement to be able to help. So the first thing that I want to do is I want to make this into exponential form. So I want that to be written as an exponent. And so that's going to be y equals x to the 1/2. The second thing is I want to bring that out of the denominator, the x cubed. And so that's going to become minus 5x to the negative 3. Now when we multiply, so I'm going to distribute this through, when we multiply and you have the same base, you add the powers. So this is going to become y equals, well, 1/2 plus 2 gives me x to the 5/2 minus 5. 1/2 minus 3 is going to give me, just to visualize it for you guys, negative 5/2. That'll be x to the negative 5/2. So now, got to take the derivative. So y prime equals 5/2 x, now minus 1, so minus 2 over 2. And then this is going to be minus 5 times negative 5/2 minus 2 over 2. So cleaning this up, y prime equals 5/2 x to the 3/2. This will be plus, I'll say 25 over the 2's in the denominator, and I have to bring that into the denominator, so x to the 7/2. And so that's going to be our answer. So to conclude this lesson, we talked about the power rule, and we can use the power rule to help us when we are taking the derivative. And essentially it just says when we have a term in the form of x to the c power, you take that c, you multiply it with the coefficient, and you subtract c by 1. This does conclude our lesson. If you have any other questions, please leave them in the comments.